Hello, hello. All right, so today we're going to be going over biochemistry, hormones, Q2. Yes, you are moving around. All right. There we go. And my computer's been out for the last week. Week before that, I was in Utah for a wedding. Not sorry for that, but sorry that you didn't get a video. So let's go ahead and start with all the hormones, all of them, all at once. That's what this is all about. All right. No rest for the weary. So first, I'm going to go ahead and divide our thing like this. We're going to have three major topics. Categorizing hormones in general. Then we're going to say which hormones come from where and what do they do. Once we cover those, we're good. So first, what is a hormone? What's the definition of a hormone? Anybody want to take a stab? It's one of those things that everyone just throws it out and no one ever bothers to define it, right? So makes a cellular response. Very good. That's half the definition right there. Regulated, that's another quarter. And then the last one is that it travels through a particular place or in a particular thing. Blood. Blood. All right. So hormones are signaling molecules that travel through the blood, so they're systemic. You can have things, neurotransmitters, those aren't systemic. Those are right there. You can have paracrine, which is just a cell releases it, talks to the cells next to it, doesn't go in the blood. So hormone is the one that goes through the blood, goes everywhere. All right. So once we have the definition of a hormone down, there are a couple different forms that hormones can take. They can be steroid, which means that they have a ring, they're pretty hydrophobic, not hydrophilic, they're fatty. Or, so that's one group, steroid. Or they can be almost just an amino acid, but tweaked a little bit. We call those amino acid derived. Or they can be peptides, which is just a bunch of little, they have peptide chains, they're proteins all hooked together, and they're like most of our molecules. So they aren't a single amino acid, they aren't steroid, they're just strung together peptide bonded molecules. So, with those three families in mind, we're going to go ahead and say those little molecule ones, peptides and amino acids, amino acid, peptide, those guys, by and large, when they are released from wherever, they'll go into the blood, and eventually they'll find their receptor. And that receptor is going to be on the outside of the cell, which is what you're probably most familiar with. In phys, the receptor is like always on the outside. There's always a little stick there. It sticks to the thing. It does stuff. So these guys will bind to external receptors. That's something that you want to make a note of. She'll ask. Then we have steroid and one other guy. Question? No? Okay. Sorry, I'm like hyper-focused because I've been tutoring for like 4 hours now. So but steroid, yeah, so steroid is going to go ahead and be intracellular. Why? Because he's fatty, and so he can just diffuse through the fatty membrane. Not a problem. So he goes straight through it, and the receptor that is inside is usually inside the nucleus. That says nucleus. Now what happens after the receptor gets stimulated, whether it's on the outside or the inside? It turns on some messengers, and it goes and changes what is being made in the cell. The ones in the nucleus, so steroid hormones in particular, they will mess with DNA synthesis, saying, make more of this, make less of that, turn this gene on, turn that gene off, that kind of thing. This guy usually will also indirectly mess with the DNA, but what you really want to know is external, internal. Steroid goes inside. They diffuse. All right. Any questions on that so far? Question over here?
Yeah, you said peptides and
Amino acids, with one exception, which I'm about to get to, which is why there's a plus underneath the steroids. All right, so there is an amino acid hormone that is known as thyroid hormone, or T4, T3. That one has a very special transporter that lets it get inside of cells. And so its receptor is actually inside, even though it can't go through without help. So it's not binding to an external receptor. It's being shuttled inside, and then it's acting on a receptor inside. So steroid and thyroid. Notice it's in red because that's the one they're going to ask you because it's the exception. And they love you dearly. All right. So these ones usually have a ring because they're fatty steroids. And then there's the thyroid hormone, which is just a little dot because it's just an amino acid. All right. So, good. Let's talk a little bit more about the other amino acids, the ones that behave like we'd expect them to. Those are going to be, let's get rid of all these beautiful dots. That makes me think like I'm trying to make the American flag or something. All right. We have catecholamines. It took me forever to have any idea what this word meant because it would come up and then it would be gone and then I'd say, whatever, I know what the rest of the words mean, but that one's not important, except it is. So, does anyone want to know what the word does anyone know what the word catecholamine means? Neurotransmitter's a good one. Lots of catecholamines are neurotransmitters. There are some that aren't catecholamines though, so that's really good. Anything else? Acetylcholine, that's good. It's got choline in it right there. Good. You also have dopamine, epinephrine, norepinephrine. Those guys are in there, so excellent. So they are most of our prevalent neurotransmitters. So I'm going to put neurotransmitter up here, / dopamine, epi, and norepi. Sweet. Those are amino acids. And the amino acids that they are derived from, particularly dopa, epi, and norepi, do you guys remember tyrosine? Excellent. Yeah, you guys don't need this, you've already got it. All right. So we have phenylalanine to tyrosine, and then tyrosine to dopa, and then dopa to epi and norepi. So it's just a chain from phenylalanine to tyrosine to dopa to epi to norepi. Just in that order. And you guys have that on a slide. I think it was, in my slide said it was 38, but that's just something to know. But if you can categorize those as amino acids, great. Peptides. These are the ones I'm not going to list for you because it's everybody else. So I'm just going to write everybody else. Most of these come from the pituitary as the big player. All right. So, big picture, lots of hormones. Some of them act on the outside and send a messenger. Others get inside and act on receptors inside and on the DNA directly. Okay, any questions? That one, phenylalanine to tyrosine, tyrosine to dopa, and then dopa to epi, and epi to norepi. So it's just a chain of going from the amino acid all the way to the product. And I squiggled it in the corner because I wasn't anticipating writing that there. It's on slide 38, and it's got it nicely laid out. Everybody else, especially the pituitary, yeah, you got it. Good? All right. So, steroid hormones, really quick. Some steroid hormones. Does anyone know a steroid hormone that they'd like to yell out? Estrogen, excellent. Testosterone, I think I heard. Progesterone. All the ones that have stir in them. So steroid, estrogen, progesterone, yeah, forcing it, but there you go. Testosterone, cortisol. Wait, hang on. Cortisol is not a steroid, is it? I'd have to double check on that one. I felt like that one was made in the,
Yeah.
is it? Okay, sweet. All right. So a lot of the sex hormones are steroids. So now that's the basics. Next, let's talk about all the organs that are going to make these guys and then what they do. So first, let's talk about the ones that have receptors on the outside. All right, so for this, we're going to start with the pituitary. That is a brain representing the hypothalamus, which we're going to need to talk about. And then here is our anterior and posterior pituitary, divided into two. In the posterior pituitary, two hormones are going to pass through it. They pass through, however, and are not made in the posterior pituitary. The hypothalamus makes them, and then it just sends them down like a slide. Nothing really happens that we care about in the posterior pituitary. Straight from the hypothalamus into the blood. Those two are oxytocin, everybody's favorite, and ADH, also known as arginine vasopressin. Same thing. All right. ADH, antidiuretic hormone. And then arginine vasopressin is the same thing, but in the name it has vasopressin. These two names are named after its two different functions, same molecule. One of them is preserve water, don't pee it out, antidiuretic hormone. And the other one is to tighten your vessels, vasopressin. So it can help raise your blood pressure by retaining fluid and then tightening your vessels, and that brings your blood pressure up. That is the function of ADH. Cool. So raise blood pressure by retaining water and tightening vessels. Oxytocin. And we'll go ahead and actually say that they were made in the hypothalamus. Like so. It starts in the hypothalamus, goes all the way down to the blood. All right, oxytocin. Anybody want to take a stab at what that does? I heard a couple things. I think I heard attraction or contractions. Both are correct, actually. So, all right, so oxytocin, contractions during labor. It also can deal with attraction. It makes a feeling towards something stronger, whether it's a positive feeling, which everyone likes to talk about, or a negative feeling, which you'll only find in the literature, because no one talks about that, but it's fun in a interesting kind of way, I guess. I want to know how people hate people so much. All right. So, increases, dang it, whatever. We're going to say bonds, whether they're positive or negative bonds. All right, those are two for oxytocin. All right, that was posterior pituitary. Where are those made? Hypothalamus. That's going to be a question. Yes. So they'll go from hypothalamus, and then they are going to go into the posterior, and the posterior will secrete them into the blood.
So the both
You got it. Yes. Yep. Question was, were we talking about ADH and oxytocin? Yes, that's what all that was about. All right. So Now we're going to talk about the anterior pituitary, which has a lot more going on. So let's go ahead and, we'll go ahead and do a nice little chart. So we're going to have the hypothalamus, then we're going to have the pituitary, and then we're going to have what is released into the blood. All right. So when the hypothalamus is talking to the pituitary, the anterior pituitary, it is going to say, pituitary, you've made a whole bunch of hormones that I didn't make. I just got word from the body, however I did, that they want those. Can you please dump them into the bloodstream? So hypothalamus just asks the pituitary to do the actual work. How does the hypothalamus do that? It does it by sending releasing hormones. So, for example, growth hormone releasing hormone. Adrenocorticotropic, ACTRH, whatever. Yeah, ACTRH, adrenocorticotropic releasing hormone. Then you can have thyroid releasing hormone, TRH. Then you can have gonadotropin, GN, releasing hormone, GnRH. Then you have one guy who's weird. So we're going to write him in red, and that's the one you're going to have a question on. Just if I was making the test. I don't actually remember what her questions are. Most of them. All right. All of these were releasing hormones. They're telling the anterior pituitary, go ahead and take your basket of hormones and dump it in the blood. This last one, dopamine, is in red because it's actually saying, hold on to your basket. No, don't dump it. No, stop. Keep it. Don't. Watching you. As soon as dopamine stops, then that hormone will be dumped into the blood right away. And since we're talking about it as the exception, let's just go ahead and go through the whole thing. What is that cell? So the hormones are going to be made and stored in particular cells. And this one's going to go ahead and be a lactotroph is the cell. And then the hormone that gets released into the blood would be prolactin. So for guys, for example, dopamine will be coming out of the hypothalamus for our entire life. We never need to have prolactin, which stimulates lactation or milk let down from the breasts. So dopamine would be going for a guy's entire life. After a woman has a baby, then dopamine will be inhibited, and so you won't have any of that coming out, and this will just go ahead without any further signaling, with the dopamine no longer saying stop. It'll go ahead and you'll have milk let down. Make sense? Maybe?
What is that little word saying?
Middle one says lactotroph. So pituitary, let me go ahead and clarify that a bit. Pituitary cells, these are the cells of the pituitary that make the hormone. They have special names. And then this last one says blood, so let's say hormones. Hormones that are released from the pituitary. So here's the cell that makes them, and then these are the hormones that are made. Okay, good question. Dopamine will tell the lactotroph, hold on to all your prolactin and don't give it away. And so guys always have dopamine there saying, don't send any prolactin out. Just hold it right there and never let it go. As soon as a woman has a baby, this is what happens. Dopamine goes away. Then this just happens continuously for about, well, as long as they nurse, which can go on for a long time. Did that help? Okay.
So, the lactotroph is part of the pituitary cell?
Yes. The lactotroph is part of the anterior pituitary. It's a cell that makes and holds on to prolactin until it's needed. Kind of like a basket. It's just waiting for something to tip it over into the blood. Good? All right. The rest of these are much easier. So GH, RH, ACT, all the ones that have R in it, if you see the letter R, you know it was made by the hypothalamus because it's a releasing hormone. The next ones, all the cells have their special names. We'll write those up. I'm trying to remember, I know in Phys you talked about the special cell names. Did she mention those in Biochem? No? Somatroph,
Yes.
lactotroph.
Yes.
Yes? Okay, then we'll hit those. All right.
Well, some of them.
So the somatotroph is like the somatotropin, right? The SR, remember the inverse.
Oh, okay. So somatotroph and somatotropin. Troph means it grows something and it does something, so it's a cell. Troph, these are all going to end in troph, all the cells. Somatotropin is a substance, and that substance is going to have actions turning off some of these guys or something like that. And so it's like, oh, we want to turn off the somatotroph, let's send somatotropin to go find what it's named after and turn it off. So that's why they sound similar, is because one of them says, go find that guy and turn it off, name them similar. Did that make sense? All right, we'll get back to the somatotropin later. We're just going to do straightforward creation first. All right. So GHRH, growth hormone releasing hormone, is going to talk to the somatotroph in the anterior pituitary. And somatic means body, right? So like the somatic nervous system was the one where you could do skeletal muscle movement for the whole body. So somatotroph, we're going to have growth hormone, which grows the whole body, being the one that comes out of there. Growth hormone releasing hormone, somatotroph, growth hormone. Good? All right. ACTRH, or adrenal, which is really the only part you need to remember because it's the adrenals. Adrenal releasing hormone, adrenocorticotropic releasing hormone, that goes to the adrenotrophs, and it releases adrenocorticotropic, ACTH, hormone. Next one is TRH, which is going to be thyroid. Oh, Lindsay, go on.
You said that adrenocorticotropic
Yes, certainly. So let's do those as we go along a bit. Growth hormone. Grow body. Adrenocorticotropic releasing hormone. Excuse me, not releasing, but ACTH. That is going to go ahead and release, let's see, how can I put this? It'll give you an adrenaline rush. Adrenaline. So epi and norepi. So your adrenals are where your adrenaline is stored, or your epinephrine, norepinephrine, and that will be released so that you can fight or flight. Yeah. All right. Thyroid releasing hormone is going to go ahead and have thyrotroph, and that's going to release thyroid stimulating hormone. That's going to go ahead and tell the thyroid, make more T4, T3, T4, which means increase your metabolism. So, grow body, adrenaline rush, metabolism.
The G8 are the G8 hormone.
So
It's not directly growing the body, right? It makes them more.
it does make, we're going to go into them a little bit deeper. And yes, there is another one. And since you bring it up, growth hormone, I want to have each of their stories where we go into like the details when we get there. So this is kind of a summary. It's not every step. Thankfully, most of them aren't too complicated. All right. So then we have GnRH, which is gonadotropin releasing hormone. And that's going to go to the gonadotrophs. And the gonadotroph is going to go ahead and release two things, because gonads are the reproductive organs. And there are two sides of the reproductive story for both men and women. And so we have one hormone that controls one side of it and another hormone controls the other side of it. For women, there's the follicle, and then there's the corpus luteum. And so we have one hormone for each of those. And that's going to be follicle stimulating hormone for the follicles and luteinizing hormone, or LH, for the corpus luteum. And so this is going to be follicle. This is going to be corpus luteum. And that's in women. And so in men, this is helpful if you memorize it now, bless you, because it comes back a few times, and it's always like, well, in men, which one does what? Because they're not named after what happens in the guy. Sertoli goes with F. So Sertoli cells will be stimulated by FSH. Whereas Leydig cells in men will be done by LH. The L goes with the L, the S goes with the S. Sertoli, FSH, LH, Leydig. Make sense? That's a no. Okay, so there are two hormones released by the gonadotroph. One of them is FSH, the other one is LH. One of those hormones will turn on something called Sertoli cells, which are part of the reproductive system in men. And then others will turn on the Leydig cells. FSH has an S in it, just like Sertoli starts with the letter S. And so I just remember that those two go together. And then LH has an L in it, so I remember that that goes with Leydig. So the first letter of whatever's in the guy should be in the hormone as well. So men is the second column here. Sertoli and Leydig are in men. Women have the ones that it's actually named after. Follicle stimulating hormone, women have a follicle. Luteinizing hormone, women have corpus luteum. Thankfully, all of that is, you'll get those ones in more depth and you'll have a lot more time to become familiar with them. So really all you need to know is the target cells, then that's probably good. Because you'll have a few weeks of class making that clearer. All right. So let's go ahead and do a little bit of quizzing. We're going to do a review. Okay. Before we do review, let's see, was there some memory stuff that I had for this? With all of the cells, they're named after what they're going to go and do. Soma, body. Adreno, adrenals. Thyro, thyroid. Gonad, gonads. And honestly, that's how I remembered the cells. I didn't do a fancy memory trick thing for those because it's kind of built in. Lacto, lactation. And then for each of the hormones, kind of as not stimulating, but inhibiting, which is the dopamine. Yeah, I can think of a couple other things, but I think it'd make it less rather than more. So, all right. So, when you're done with notes, go ahead and look away from your notes and close your eyes if you want, or just whatever. And I'm going to ask you guys a few questions, see if you can answer them. All right. How many hormones go through the posterior pituitary in your head? All right, and those 2 hormones is how many that was? And where are those 2 made? They're made in the hypothalamus, and then they just slide down through the posterior into the blood. Those 2 have what names? What are they? One of them was ADH, or arginine vasopressin. And then the other one was oxytocin. All right. Now, let's go to the anterior pituitary. How many hormones are going to go and come from the hypothalamus to the anterior pituitary? Hypothalamus releases how many different guys, potentially? 5. All right. So, those 5 are all releasing hormones, except for one guy at the end. And what was he? Instead of a releasing hormone, he did what? He's an inhibitory hormone. So he's actually saying stop it instead of go. Okay, now let's just go line by line. We have see if you can remember what was the first hormone, I guess. What was the first hormone from the anterior, from the hypothalamus that releases, which goes down to tell the anterior pituitary to release something? That was GHRH, growth hormone releasing hormone. Okay, and that's going to go ahead and act on what kind of cell? Knowing that growth hormone affects the whole body, it is the somatotrope. All right, the somatotrope is going to have what inside of it that it's going to dump into the bloodstream? Growth hormone. All right, next line. That's going to be the adrenocorticotropic releasing hormone. What are the other details for that one? What's the cell and what gets released? The cell is adrenotrope, and what's being released is adrenocorticotropic release. I always want to throw the releasing in there. It's like as many syllables as possible. But adrenocorticotropic hormone helps with adrenaline rushes. All right, next one down, that's going to be the thyroid releasing hormone. What are the other 2 things for the thyroid releasing hormone? The cell and the hormone. Thyrotrope and thyroid stimulating hormone. That's going to go ahead and tell the thyroid to make more thyroid hormone. All right. Then for the gonadotropin releasing hormone, what are the 2 things for that? All right, gonadotrope, and then that splits into 2 different hormones, which are FSH and LH. All right. Then the last one, that was the inhibitory one, that's dopamine, and that messes with what? Lactotrope, which? If no one is stopping it, it will release what? Prolactin. All right, that was a lot. We can move from here. This one, we will hit a little bit more for these. Other details that you would want to know is, before we go into more details though, any questions, any trouble spots? Yes. These are peptides. So all of these are going to be extracellular. They're acting on the outside.
In her preface, she mentions melanocyte stimulating hormone.
Okay. Melanocyte is actually part of the ACTH. So when you make ACTH, you also make melanocyte. I forgot she talked about that one. Let's see, what was that called? What was the hormone name for the melanin thing? Melanocortin? Melano stimulating hormone?
Yeah.
Okay. Melanocortin is what? Don't worry about that. Okay, so, yeah, melanocyte stimulating hormone is also made along with the ACTH. Right, it goes and makes so that you have more melanin, so your skin gets more pigment.
So it's an adrenal.
Yeah.
What is that compound ACTH?
So cortisol is going to be made in the adrenal glands, and ACTH talks to the adrenal glands, so they're connected that way.
She also has dopamine amino acid.
Yes, so most of these are peptides. I should have been very clear. I just kind of blanket said they're all peptides. This one is an amino acid. And all of them are acting outside the cell. And that's what all of these are going to have in common. Melanocyte stimulating hormone. Yep. So your adrenotropes would make both ACTH and MSH, and both of those would be released into the blood. Good question. So the way that I would practice this on my own time is I would either list the cells or the hormones, and I'd just like make 5 flashcards, or maybe 10 if you want to do both, and just say, what are the 2 things that pair with this? What are the 2 things that pair with this? What are the 2 things that pair with this? And just go through, what are the 2 things that go with somatrope? GHRH and growth hormone. What are the 2 things that go with thyrotrope? Those ones. And eventually it gets, they have like the same beginning letters most of the time. And so they can pair together pretty quickly, but when it's new, it's a lot of words. So that's how I would just go over it for an hour or half an hour or something like that. And then it'll all come together. All right. So, we good to move forward? Question? Okay, so when we're talking about thyroid hormone, not thyroid stimulating hormone, this guy, the thyroid, actually has a transporter that will grab the thyroid hormone, T3 or T4, and bring it inside the cell before it talks to the cell at all. And so it hasn't touched a receptor, and yet it's gotten inside the cell. And so its receptor is inside, even though it can't just, it needs help to get inside. Steroid hormones can just float through. This guy needs help to get in. Both of steroid hormones who can get in for free, and him who has to have help, their receptors are inside. Cool? Okay. So, with this, let's see, are there any last details here that need to be said for what she expects you to know? hit that one more. The only one that we're not going to hit later is the one with the growth hormone, and that is that when you're sending growth hormone into the blood, that's going to go and talk to the liver. And then the liver is going to make insulin-like growth factor 1. So this guy will go to the liver, and then the liver makes the really powerful growth factor, insulin-like growth factor, IGF-1. IGF-1. And IGF-1 goes to the whole body and says, grow, be big, make a lot of everything, muscle and bone and all the stuff, organs, and do it all. So that's what you'd want to know, is that growth hormone turns on somebody else. And then the rest of them will hit as we go on. All right. Next, we have the pancreas. Pancreas, as drawn by me, looks like that. And it's pretty friendly. It has 4 cell types that you need to know. 2 of them make hormones that you're very familiar with. And then 2 of them make hormones that are just regulatory, saying, don't make too much. You've got, and then it's almost like doing your ABCs, because you have alpha cells, beta cells, then you skip down to delta, and then you have F cells, because they apparently don't like the letter C or D. Delta for gamma?
No, she's not. Yeah, she was saying instead of F, it was.
Oh, she liked gamma instead of F?
Yeah.
She said something like, yeah.
Oh, that would make sense. I thought the F thing was kind of out of place. All right. All right.
Yeah.
Alpha, beta, delta, gamma. All right. Alpha and beta are going to make guys that we have talked about a lot, which is nice. Alpha makes glucagon. When would you need more glucagon? Fasting, when the gluc is gone. All right. So that's what would stimulate this guy. Makes sense. Beta cells of the pancreas. And these are things you'll hear about clinically. People who have type 1 diabetes, often their beta cells have been attacked by the immune system. Occasionally they had some kind of mutation in the DNA and they just never had them. But usually somehow these guys got screwed up, and so that they don't have insulin. Cool research, by the way, in regrowing beta cells. Ask me about it some other time, but it's awesome. They have been able to get mice to regrow beta cells from having none, and it's really promising. So yeah, alpha, glucagon, beta with insulin. And if you want a way to remember which one goes with which, if it doesn't just click, glucagon has an A in it, which goes with alpha. All right, those are the 2 big ones. Then you have the regulatory guys, delta and gamma. Delta, this one I believe makes, I'm going to need a little help on these. I think it's somatostatin. Okay. Somatostatin, and then I believe gamma made peptide hormone. All right. Polypeptide. And I believe I have heard it shortened to just peptide hormone. And that's not saying it is a peptide hormone, but that's actually its name. Is the polypeptide hormone, that one. It's like someone couldn't be bothered to name it. So these guys will both regulate the other ones in the pancreas. And so they just say, turn off a little bit, turn on a little bit. That's their deal. You'll learn more about them later. Okay, so we had 2 main guys, 2 regulator guys. Question?
The 2 bottom ones, you said were the regulatory ones?
Yeah.
What were the 2 top ones?
Those are going to be your main hormones. They go out and do a bunch of awesome stuff.
And what is the gamma?
That's a delta. It's a very badly drawn delta.
When a somatostatin directly goes to the regulates the insulin,
Oh.
polypeptide, okay. Both does both.
You'll have a class where you talk about what they do. It gets a little bit hairy. Just know that they go up and talk in general. I shouldn't have drawn clear arrows. I don't think that you've had that yet, where it's like this turns off this, but this turns off those, and so if this is off, then this, yeah, and it's like, did you? Thyroid hormone. Thyroid hormone does some things too. I think it is phys where you do get it, so maybe you have, or maybe you'll get more of it later. He tends to mention and then go in deeper as he moves on. But for biochem, this is good. And among other things, yeah. Okay, so he has gotten to how it affects up here. You'll also find how it affects down here. All right, so somatostatin can go ahead and, yeah, it can turn off some of these. It also can turn off some of these. So I'm just going to put a red underline and say it's an inhibitor of various substances. And that'll be enough for biochem. All right, that was the pancreas. I feel like I spelled that pancreas, but whatever. All right, it's probably spelled right, and that's why it looks wrong, because I don't do that very often. Great. There, it's even pancreasi, it's multiple pancreases. All right, next we're going to have adrenal medulla, or medulla if you like that pronunciation, drives me crazy. All right, so the adrenal gland has multiple layers. There's the medulla, and then there's the cortex. The medulla is split into two layers, and those first two layers are going to be making hormones that act on the outside of cells, so we're going to talk about them here. Those layers are called the, well, rather than naming the layers, I'm going to name the hormones. We have mineralocorticoids. Medulla. Excuse me. Wait, medulla, cortex. Cortex. This is cortex. I always want the cortex to be in the core, and so I always try and make that at the center, and it's not. All right. Cortex. The adrenal cortex has mineralocorticoids and glucocorticoids. Inside the medulla, which I'm going to go ahead and throw over here, you have steroid or androgen. Same thing. Androgen, which are steroid hormones. Going from the outside of the adrenal gland to the inside, the way that I like to remember this is the outermost layer does salt. It goes from least sweet to most sweet. All right, so it starts with salt, which is going to be aldosterone. There we go. This is cortex. And then we're doing medulla kind of at the same time. All right, but right now we're talking cortex. Mineralocorticoids, which regulate salt, such as aldosterone. Glucocorticoids, which regulate sugar, among other things, such as cortisol. And then the last one, androgens, which regulate sex hormones, such as testosterone. So salt, sugar, and then sex hormones, from outside to the inside. Someone once said that it was from the least sweet to the most sweet, and that was how they remembered it for the layers. And that's done.
Androgen, what is that?
Androgens are just the category of hormones. So mineralocorticoids is a category of hormones. Glucocorticoids is a category of hormones. This one is medulla. It says sugar. And that's because cortisol is going to help move more sugar into the bloodstream and reallocate it to other places. A stress hormone will change where your food sources are moving. So it messes with blood sugar. Cortisol. Please.
Okay, so when you say the mineral corticoid, that's the category, how is that, it's releasing the aldosterone?
Yes.
Okay, so is that kind of like when you take an impact into some other course?
Similar, although when we say mineralocorticoids, we aren't talking about a cell, versus up here the somatotrope is a physical cell that actually makes it. An example of a family being referenced, glucocorticoids. We make a lot of, in America, we make a lot of drugs that are glucocorticoids, and we administer those. And so if you ever hear someone saying, oh, they're taking a glucocorticoid medication, they're not telling you exactly what kind of drug it is, but if you know it's a glucocorticoid, you know it's messing with receptors similar to what cortisol would. And so then you can know something about that drug family that's all messing with glucocorticoid receptors. Which means that they're all pretending to either be cortisol or block cortisol, or something similar. All right. So, question. Here and then there.
But in the electric cell, we also have the androgen.
Testosterone. Androgens are in the medulla. Yeah, I know, it's, can't see it with this thing there. So, in the medulla you have androgens, and those are sex hormones. One of those, the example is testosterone. Yeah.
I'm trying to think of the song. Is the S coming from the end of the middle corticoid? And then you get aldosterone next, filling out AL.
Sorry?
Where do you get salt from?
Salt? Oh, okay. Aldosterone messes with where salt is, and it messes with blood pressure levels by changing where salt moves. Thank you for asking that question. I should have clarified that. So, mineralocorticoids play with salt, which means they play with where water goes. Glucocorticoids play with sugar, which means they play with the cells getting the resources that they need. Androgens play with all of the hormones that have to do with sexual reproduction. They also have a whole bunch of other functions. And so that one's just kind of an easy way to remember. They're called the sex hormones, but they have a lot of other functions. All right. So let's pause for just a moment. And let me take a look here. So how many people would like to keep going with Biochem? And Phys can, and okay. And how many would like to switch to Phys? Okay. We will go ahead, we're going to do a recall on this, and then we're going to pause for a little bit and let our brains cool off, and then we'll jump back in on Biochem. All right, so recall first. I'll guide a recall. If you want to go and take a break now, that's totally cool. I'm going to go ahead and lead a recall on the pancreas and on the adrenal gland. All right, so go ahead and close your eyes, look away from your notes. And for the pancreas, how many different cells are there in the pancreas that you are wanting to know about? Whether you want to or not. Zero. All right. So there were a total of 4, 2 sets of 2. The first 2 are going to be what? Alpha and beta. What do they release? All right, glucagon and insulin, respectively. All right, what are the last 2 cells called? delta and gamma. And what do they release, respectively? Respectively meaning in the same order. Somatostatin and polypeptide hormone. All right, good. That was the pancreas. Moving on, we have the adrenal gland, the cortex, and the medulla. How many categories, how many families of hormone do we have here that we want to know about, whether we want to or not? Come on, science is fun. There are 3. All right. See if you can go through the first line and then see if you can remember first what was the from least sweet to most sweet. See if you can get that down and then build off of what were the things that went with each of those 3 layers. That was the first layer. Water movement. So salt, which helps you move water, and those would be the mineralocorticoids. Just like salt is a mineral, that's what it moves around, and that's why they were called the mineralocorticoids, is because they play with minerals. And aldosterone. All right, second layer. What was the next sweetest thing? Get myself into trouble lining it up like that. Sugar. And what were the 2 there? The family and then the example hormone. Glucocorticoids. Gluco should make you think of sweet because glucose, it's a sugar. Glucocorticoid. And what's the hormone example that messes around with food levels in the blood, sugar levels? Cortisol. All right, last layer. We had salt, we had sugar, and then we had, and what goes with that? All right, sex hormones, and those are going to be called the androgens, and then an example of that is testosterone. All right, hopefully that recall helps. Yeah, go ahead and take, okay, question, and if you guys want to take a break, go for it. I don't recall if she wants you to know that. You will eventually want to know that. DHEA is... yeah. Say it with even more joy. All right. DHEA, it is... it's in all 3, purple, pink, and red. All right. DHEA. If she doesn't want it, there's going to be like 2 or 3 other classes that do. So if you learn it now, it will be to your benefit. DHEA is, yeah, it's a precursor to lots of the sex hormones. So, all right, take 5 and see you after. I'm going to get a drink.
DHEA is a precursor to sex hormones. We're all like
Because I feel like we are all just get a lot. We sat in the study room and I didn't feel like it was very beneficial. No, I studied, but the room, I feel like we just need our own, we need our own study time and at home, like we put on music, relax and study at home. Should we get the study home together? Yeah. Wanna go get a smoothie bowl? I'm gonna get it to my truck. Why are you doing that with the tea? Good cracker. Smoothie bowl, smoothie bowl? Oh. I feel like it's a good review for Q1, because it's all the stuff we did in Q1.
I just had everything like a
Ooh, hey.
I know.
I was on my
My
way.
favorite food has
Never mind.
been used on its way too late.
Don't do that, don't do that.
I do have taco.
See, I think you don't really laugh.
She won't eat them all.
At one time, like in one day, I'm going to a diet. I'm like a hamster, I have no self-control. I'm like a hamster, I have no self-control. They'll eat as much as you put out. They'll have no threshold, they will kill themselves. They'll kill them.
Okay, you said the thyroid hormone was different because of this.
He said the thyroid hormone has its own receptor.
Okay,
So-
that's what it is.
It's not binding to the ligand on the outside of the cell, and it's not it's going through the inside, but it's going through its own channel. But the channel is just with thyroid hormone.
Okay, so it is intracellular.
It's intracellular. She's just
But
going to
it
ask you
has-
about that one. Yeah.
But it has its own receptor.
It's not binding like all the other ones bound to the ligand on the outside. It's skipping that. It has its own channel, and it's going to go right to the inside. Because I guess it, does the thyroid hormone, is it a fat soluble? No. It's not a step?
No.
So it's a peptide hormone, so it's water soluble. That's why it needs a channel.
Actually,
Okay.
so that's how we can do it. But my question was what he was talking about. So the thyroid hormone is intracellular, but it has its own receptor, so it doesn't bind to the ligand on the surface of the nucleus.
But it does directly go intracellular. It's intracellular. Right? That's what it means to me.
Okay, so it's intracellular with its own receptor.
Yeah. Lisa has one on this.
What is it? What's the list?
What was he saying specifically about the thyroid hormone? He was saying that it's, I know it's intracellular, just like steroid hormone, but
it goes to the nucleus.
Yeah. No, what? You don't know if it's water soluble or fat soluble, the thyroid.
I don't. This isn't transported. If he draws it, then it has to go through those red lines.
Yes. So it has its own receptor, but we're trying to figure out what makes it different than the other steroid. Is it not a steroid?
It has. And the thyroid hormone is not a steroid.
It's an amino acid that's acting like a steroid.
It's an amino acid derivative hormone.
No, it's just going in the
It's one of the it's one of the peptides. It's a peptide.
binds inside the cell and outside.
Okay.
So the steroids go to the nucleus and the thyroid hormone goes to the nucleus, but the steroids go straight to the nucleus.
Because they're fat soluble. But I think the difference is the thyroid hormone is a peptide that is kind of like mimicking the steroid. And it has its own channel.
No, it doesn't. That's the example.
Taylor, can you clarify?
Yes, it's the one in, yeah, it's what the one in red.
Yeah, it has its own channel. It goes straight through.
Right.
So it's a, just double checking, the thyroid hormone is an amino acid, it's a peptide,
It is a, let's see, thyroid hormone should be, it's one of, I believe it's a, geez, now I don't remember if it's an amino acid or a peptide, but it's definitely not a steroid, but it's over there anyway,
But it's over.
because it's got the little transporter.
And I also have something to say about that. So the Parker's, within Parker's book, the way that I found it is I logged in to my and went to the library page, and there's a library catalog. You want to find
It's
it
not like
on
the LWW.
I don't know how to find it that way.
Okay. But it's on the, it's
It's through the library.
So,
The steroid and the thyroid work straight to the nucleus.
Right.
One through a special transporter that uses, but the other ones, which were the amino acids, make catecholamines.
Amino acids, examples are catecholamines.
Oh,
Well, she had it.
and
It's like a
peptides also work
I
on
have on her
receptors.
slides, you know.
Correct. So those two families do receptors.
I'm putting both.
That family plus that one little exception of thyroid hormone goes
It's
inside the
on the
nucleus,
classification of
just like you
hormones.
said.
It's like, because there are hormones that they interpose here that are peptides, is that the one listed under amino acid?
Okay, so it's a thyroid hormone, it's a peptide.
Amino acid.
Okay.
But it's also an anterior pituitary hormone?
So, good question. Let's actually do a bit of that right away. So, thyroid hormone is different than thyroid stimulating hormone.
It
So,
is?
yeah,
Well, like, doesn't TSH make thyroid hormone?
it does. So, let's tell the story of that actually.
What's T4 and T3?
That would be thyroid hormone.
Okay. Oh,
All right. T3, T4 in parentheses. All right. It's a lot. It's a lot. All right. So here's the thyroid story from beginning to end without all the details, but just like so you know the difference between the hormones. Thyroid releasing hormone comes from the hypothalamus, tells the anterior pituitary to let thyroid stimulating hormone go into the blood. Thyroid stimulating hormone that is in the blood floats until it gets to the thyroid, and then it says, thyroid, do more work. Thyroid says, okay, and therefore the thyroid makes more of its own hormone called thyroid hormone, and then it dumps that into the blood. So this is kind of like, tell him to make it, I'll tell him to make it, and then he made it. So there's a lot of them that have the word thyroid in it. All right. And if you're really good at thyroid stuff, you can help a lot of people who have a lot of issues, and it also tends to be something that can be like your entire practice. So
And it's a peptide hormone, like
it's an amino acid hormone.
So it's an amino acid hormone that is intracellular.
Yes, for
And
thyroid
that's the
hormone.
difference between, because we do the steroid hormones like in that category, steroid and thyroid hormones.
So
Or-
steroid can sneak in anytime.
Yeah.
Thyroid, it's like, how the heck does that get inside? It has a special gate. So that's why he's the exception, because otherwise you would expect him to be on the outside like all these other guys that can't just slip through. Question there, and then there.
Double check, and the steroid hormones are lipid, they love.
Yeah, there, which is another way of saying hydrophobic,
And, yes,
fatty.
hydrophobic. And, but what's the exception?
Thyroid hormone?
The thyroid hormone is water soluble?
Yes. And that's why it's like, what the heck, how does it get through the membrane? Question here.
so the TSH hormone though is a peptide.
Yes, the TSH is a peptide. So we got peptide, and then amino acid that gets to go inside anyway.
So you're supposed to talk about that.
No, that's what we're getting to soon. Where the heck is thyroid? Cool. I guess thyroid should have been right there. So, that's okay. Yes, we will talk about the thyroid. Oh, that's right. It's because it, okay. Because this This is inside. We didn't skip anything. That's what this whole thing is, are the ones that go inside, so thyroid. All right. Any other questions before we dive in? Reforge even more gray matter. All right. And before we actually go further, one thing that I will say that helps make this so that it's easier to remember and a little bit lighter in the head is if you can simply say how many items are going to be in each category and then see if you can get all those items. Because as soon as you know you have everything, you can put it away and it's no longer taxing your mind. And so there are two things. Some are outside, some are inside. Two, and there's two in each category. So there's two things there. Here, there are 2 posterior and 5 anterior. So 5 anterior, 2 posterior. And if you can name those and those, you're done. And then here there's 4, and then here there's 3. And so if you can just say, what were the 2? Put it away. What are the 5 and the 2? Put it away. What are the 4? Put it away. What are the 3? Put it away. It sounds really simple, but at least with people that I've worked with myself, it makes a big difference if you have an easy starting point and then fill in the details and then close it all up after you're done with each segment. So that said, whatever works, and we will proceed to the thyroid. All right, thyroid. Looks like a flutterby. All right. So, thyroid stimulating hormone is what is going to come and arrive at the thyroid to turn it on. That's what we talked about over here on this side. So, thyroid stimulating hormone. The thyroid, did she go into detail about how it was made? I don't think she did. I know you did do that in phys though, and that's pretty much what the entire phys lecture was. But we'll go into detail after for anyone who wants to spend time on phys with any time we have left. For now, it spits out T4, which goes through the blood. And that T4 will eventually arrive at pretty much any cell in the body. It's just going to go everywhere because it controls our metabolism, how fast our cells work, and how fast they chew up energy to fuel that work. And inside the cell, at the cell, you have that transporter we talked about, and then it goes inside, and T3 will be changed, or T4 will be changed into T3, which means we're just taking 1 iodine away, because the number is how many iodines are on it. So we had 4 iodines, now we take 1 off, it's called T3. And that T3 is going to go ahead and do stuff. And she wanted you to know that the receptor was a specific kind of receptor because it's really super double extra cool because of sciencey things that are like, I didn't think it could do that, but it does it. And that receptor is, let's see, that was anyone have that up? The receptor that thyroid hormone goes against that's super cool, and I've remembered every time except today. And yesterday. And the day before. And ever. All right, I had it at some point, but whatever. That was the kinase, No, it's not that one.
Is it HRE?
It was... It is a kinase, and so it phosphorylates things, but it actually phosphorylates itself, which is why they think it's so cool. Tyrosine kinase, thank you. Tyrosine kinase, and I did see this at least in my version of your guys' slides. And tyrosine kinase is the kind of receptor, and it gets turned on, and then it turns on like another part of itself by itself. And they thought that was super cool, and so it's its own class of receptor. And that has some scientific relevance. I don't know how much clinical relevance it has. It may or may not. It's when it gets turned on, it will then by itself turn on another portion of itself by phosphorylating it. And it's just kind of, it auto-phosphorylates. It phosphorylates itself. Auto meaning self. Oh, I see what you're saying. So the question is, tyrosine kinase, how does it work? T3 will bind to tyrosine kinase. Tyrosine kinase will stick an extra phosphate on itself, and then it will turn on a bunch of secondary messengers. What she wants you to know is T3 binds to tyrosine kinase. The rest of the details are just so tyrosine kinase means something to you. Okay, and then that does metabolism stuff. And yeah, that's pretty much how much she wants to know about that. Thank you for the tyrosine kinase.
What's the little star?
The little star. Oh, this? That's a starfish. No, it's a thyroid.
Okay.
Good question. All right. Now, inside, this is all still inside, meaning that the receptors are inside. However, now these other ones are going to be steroid. We've already got the adrenal medulla. We've got one other. We're just going to draw an ovary. Probably spell it wrong too. And ovary. Yeah, all right, whatever. So, yeah, yay. I can tell I'm getting tired. All right. So, right, steroid hormones. Those are going to be estrogen and progesterone, which if you want to flip those, progesterone leads to estrogen. If you want to have them in order, which is what I normally do, I do that plot. It's one of those memory things. Estrogen, and then you have testosterone. So, yeah. So gonads do stuff with that. Medulla can do stuff with that. It's a really big, complex thing, and if you would like to find a place to specialize to deal with people who are having hormonal issues, this whole thing, the sex hormones, that's the one that everybody's like, but you need a specialist to get that sorted out because it's subconscious.
So they're on the inside of the inside.
Inside of the inside.
With the
Yeah.
line.
Yeah. My processing is starting to come out of my mouth. All right. Filter is down. Okay, so, yes, and really all that she wants you to know about these, they're steroid. They go to the inside of the inside. And progesterone, estrogen, testosterone, they're all sex hormones. I don't recall that she wanted you to know anything else beyond that, and so it's kind of nice. If you browse through the slides, see if she had another detail or two, but I didn't notice anything in mine. I can tell you that obviously they have things to do with pregnancy and making sure it goes to term and things like that. Question or comment?
She talks about that binding to specific sequence of DNA, and then basically how it can bind and
HRAs?
hormone response.
Oh, okay. Elements. Cool. Oh, nice. Next quarter, when she says elements in the first lecture, this is what she's talking about. Anyway, so it's actually, yeah, whatever. All right. So we talked, yeah, in genetics. I'm tempted to be like elements, but no, not doing it. Not doing it. So steroids go inside and they mess with the DNA. That's basically, these are steroids. They go inside and they mess with the DNA. Those places that they mess with are hormone response elements, often shortened to elements.
Which is why it's more than going to the nucleus.
Right, because that's where they're receptors. Because the elements are literally part of the DNA, and you go and you sit on it, and it makes the DNA turn itself on elsewhere. So it's just waiting for the, can I tell Tommy to go? No? All right, wait, Timmy. Oh, good. All right, Timmy gets his thing, he turns on Tommy, and it goes. Whatever, something. My metaphors are getting sloppy. So that's steroid hormones, and what I would say for this question. Yeah.
Okay, so you said that the steroid hormone is
It binds to the DNA itself,
Okay.
most of them. So the DNA.
And what's the element?
The element is what we call the specific part of the DNA that it binds to, because it's like, where does it go on the DNA? It goes onto the element. The hormone receptive element or hormone receiver, whatever the R stands for. That's how I memorize a lot of things. It's like, I don't need that syllable. It's not an important syllable.
The ovary, for
Yep.
all of these things, the ovary.
Yeah, the ovary and other gonadal,
Okay.
yeah, all the gonads mess with this. Ovary in particular for the progesterone and estrogen, and testosterone also does things. That's why polycystic ovarian syndrome and lead to you having high testosterone levels. Ovaries play with all of them. So, but all the gonads will be in there, so you could have that. But ovaries are the ones that produce the most, and so that's why ovary was selected in her examples.
That's why a lady can grow a mustache.
Yes. Yep. Usually when you have polycystic ovarian syndrome, you'll be, anyway, you'll be able to have your hormones shift so that you're making a lot of extra testosterone, and that leads to hirsutism, meaning hairiness.
So the organ is affecting the hormone?
Right, so if this guy gets, if the ovary gets cysts, which are fluid-filled pockets, or a tumor, or anything else that's squishing it, that makes it make extra of some hormones.
The hormones aren't acting on that organ.
So they are gonna act, but it's, so the ovary is spontaneously gonna make extra, and then that extra is gonna go and affect other things.
Okay.
And then it's actually a feedback loop. You made extra, so it comes back and says, keep going. And that's what makes it such an annoying disease, because it keeps turning itself, turning its own cycle. But you can't take care of it. So, yeah. All right. So, any other questions, Lindsay? And, oh, sorry. Yeah, that's where I'm going.
I never go on. Anyway, adrenal cortex hormone, she has a slide for that, and I don't know her name, but it's like, she has called the zona glomerulus, zona fasciculata, and zona brachiosa.
Okay. The zona glomerulosa is going to be and correct me if I'm wrong, I can tell I can't retrieve anymore. Glomerulosa, I believe, is the mineralocorticoids. And then the zona fasciculata is the lattes are what you would add sugar to, so they're going to be the glucocorticoids. And then the zona reticulata or reticularis.
They're both perfectly glucocorticoids and androgens. It's both of them are with both vasculata and
Okay. Interesting. Okay. If that's what's in our slides, do that. So fasciculata and reticularis are for both of them.
And what they
Those are the actual places, if you were to dissect an adrenal gland, you probably would be able to see, you wouldn't be able to see all the layers, but underneath the microscope you'd see 3 layers. The outermost layer, the zona glomerulosa, the middle layer, the zona fasciculata, the inner layer, the zona reticulata. And then, yeah, sure. Histology.
That's what it looks like? Like what you're thinking?
Yeah, if you cut it like that, it's obviously you can get a better picture about how thick all the layers are. I think the reticulata is a little bigger, and I think the glomerulosa is a little smaller, but I don't remember for sure. But basically, you just have this layer would be the glomerulosa, which makes salty things, vesiculata, and reticularis. And these two guys, I will have little red coloring for them, because they actually both help each other according to what your slides are saying there.
What is that inside the camera?
Glomerulosa, vesiculata, reticularis.
Oh, okay.
And reticularis and vesiculata, in her slides, she's saying that they help each other with the last two jobs, so they both do both. All right.
So we're just
Yes. Yes, it is. Medulla. Anytime you hear about a medulla, it means the middle. And I always think cortex. That sounds so cool. It has to be in the middle. It's not. It's on the outside.
So the very center is considered the medulla, and then the fascia body and the glomerulus is like cortex.
Yes. Cortex would be the outer two layers. Alright. So, with that, any other questions?
But you make it look so simple when you're like 4 years on.
I'm glad
Are
it
you
was simple.
missing something?
Am I missing something? There's probably a couple details, but this is, I went through my slide set. This is like 90% of the testable stuff.
This is very helpful. That's 48 hours. Like,
Not
that's,
even.
yeah, that's a lot of
I remember that one. That was fun.
like,
Yeah.
this is the only way to do it.
So,
48 hours.
Well, you're not 2 days for that.
that sounds good.
Exactly. How long?
We had it this morning. Today.
So,
That's not
24.
24.
Exactly. This is the only way to do it. 40 hours.
24.
Oh, I didn't know. I was on this weekend. I thought maybe you guys had it earlier.
In the slide, she had the red, like the catecholamines or medical transferase.
Okay. Catecholamines. We talked about how they do phenylalanine to tyrosine to dopa to epi to norepi. That little pathway there. That's just, she wants you to know the pathway of how they're made. And I believe that the enzyme you mentioned is just one of those enzymes in the pathway. She also has a couple other, like before dopamine, you have L-dopa. So there's a couple steps that I did not write because they weren't active intermediates. But on, I believe it was slide 28 or 38, you have those other intermediates, but basically it's just phenylalanine to tyrosine to dopa to epi to norepi. The other ones don't really matter much.
Do you have to know specific
What do the rest of you guys think? I don't remember what she wanted.
Just for this pathway.
Yeah, this is the only pathway. I know that this is the only one that she focused on. I just don't remember how deep.
This is like the video.
Oh,
Yes.
yeah. Oh, jeez. Okay,
Yes, that is what I was talking about. Yes.
so,
It's, well, on my slide, so it's 43, but I added slides. I think it's 41.
okay, so that was a good thing to bring up. MAO and COMT are things that chew up the epi and the norepi. So MAO and COMT, that's how you break down the epi and norepi and make it stop doing its thing.
Is there one specific for one?
No. MAO is everywhere, including nerve endings. COMT is not in nerve endings, but it's everywhere else. So, MAO, like Sharon and MAO, is everywhere. Don't say anything. All right. And then COMT is not in the nerve endings. Because it's not. Not in nerve endings. Completely illegible.
And they only break down epi and norepi.
Yeah, or norepi.
They break down the epi and norepi. So catecholamines in general, honestly, I think. All right. Yeah, we can throw the catecholamine story down there because it felt like we'd already done it. Okay. Cool. That definitely is everything that I did have prepared though. So the rest of it, if you browse through the slides and just, if anything doesn't look like, oh yeah, we sort of talked about that. Yeah, we talked about that. She didn't talk about this. If there's anything she talked about that I didn't, go through and look at those. But this is about how much I took to take the quiz you guys are about to take. And it worked out for me, all right. And so I expect that it will do the same. So,
Do you think that the stimulatory G proteins and inhibitory G proteins are important?
stimulatory G proteins and inhibitory G proteins, those are, if you're familiar with what G proteins are, like from phys, a receptor turns on a G protein, he goes and makes the stuff happen in the cell. The amount that you got from phys is good. You don't need any extra.
Would that work have gluten?
That's for a whole lot of things. Any of the guys who do receptors on the outside,
Oh,
how do they get their stuff to do anything inside? G proteins, most of the time. So you'd have a G protein right here, and then it would do adenylate cyclase, and then it would make cyclic AMP, and then that would go and do its jazz. And cool deal. Any other questions?
No, do a pose, do a pose. No, you're covering it.
That's the one you got? Nice. Oh, delightful. Oh.
You want a different picture?
No. Oh, okay. Too much good times. So, everything gets funny the later it gets into the evening. So, yeah, we can hit phys for anyone who would like to do that. Otherwise, good luck with your biochem. Kill it. And we'll take 5, and then I'll start up phys. All right. Cheers, guys.
How long have you been for?
Probably like half an hour. It's not very much stuff. I'm just going to do thyroid.